In the last video, I said that we are going to take the triangulation approach to phenomenology or conscious experience per se and experimental data and theory. So what are the critical experimental data for consciousness research? That's the question. And primarily, to understand consciousness, we need a multi-level approach. Of course, we need to pay attention to brains in humans and also animals. And that means that we need to understand neurons and the population of neurons and also areas level of the understanding. And then connectivity of the neurons, anatomy. And then also we need to pay attention to what kind of the neural activity or connections do not really relate to what we consciously experience. So that's a problem of the non-conscious activities. And also behaviors and also cognitions. That's sort of the report about phenomenology is also important, both in humans and animals. Verbal reports in humans, simpler responses of the button press for both humans and animals, or monkeys, or other kind of a creative behavior response in different animals are also important. And then complex behaviors as well, like something that we can record from motion capture and so on. And then all of these culminated around 1990s, where people started to apply the neuroimaging techniques to wakeful humans who can do reports about consciousness. And we know that what kind of conscious experience I have. And then also at the same time to look at the brain activity. And that's kind of the dawn of the modern neuroscientific research of consciousness. So around 1990s, neuroimaging experiments applied to humans was giving rise to many different kinds of studies on the consciousness. And many of them have a title such as neural correlates of visual consciousness and things like that. And one of the remarkable finding among this neuroimaging study of consciousness is the following. So this study by Adrian Owen, published in 2006 in Science, asked the people to imagine either playing tennis or walking around the street or on the way back to your home. And then as you see on the left side of this image, when you are asked to imagine playing tennis while put into a scanner and then lying in the bed, and then closing your eyes, then this part of the brain called the supplementary motor areas around the center of the brain, around here, becomes quite active. On the other hand, if you are imagining walking around the building or a home, then several landmark areas become active, such as the parahippocampal place area and posterior parietal cortex, and also premotor cortex. These are related to motor movement and the recognition of the landmarks, and also a sense of the orientation of the walking environment. And the critical thing in this experiment is to ask the question: what happens if you do the same experiment on the people who cannot speak? And then this question was quite important at the time because they had an access to this patient who had a very huge, lesions in the front part of the brain. And because of this, massive damage, that patient was once diagnosed as a coma and then to move to persistent vegetative states. Both of them are categorized as completely non-conscious states. And then maybe that patient, according to some people, primarily family, and also some of the experimenters that tested, response to the pain or, their own name, that patient sometimes looked kind of conscious. But according to the clinical criterion, that patient was still categorized as a non-conscious vegetative state patient. So the question was that even though this particular patient was unable to express their consciousness through the verbal reports or many kind of motor behavior, maybe that patient is inside, conscious, that was what Adrian Owen and others were hypothesizing to test. And then, in fact, when they did that, when they did that experiment, and here's what they found when they did the experiment. So top left is again the tennis imagery, and then this particular patient, as you see, this is a huge destruction of the frontal part of the brain, right above eyes. As you see, there's a huge destruction and damage, but just behind it, these supplementary motor areas of this patient was quite active when they are asked to imagine tennis. And similar kind of pattern of the activity was observed for the posterior parietal area and parahippocampal place area and the posterior parietal cortex and the premotor cortex when they are imagining spatial navigation. And this activation was induced by asking people to do this imagery. So even though this patient couldn't express their conscious experience through the verbal report of made in motor behaviors, if they were allowed to give some kind of chance to express their experience, then this person was really likely to be conscious. That's the kind of the conclusion we can make. And this is quite remarkable and also impactful study that opened up lots of clinical studies of consciousness, because now combined with the brain imaging, it's now potentially possible to improve the diagnosis of the brain damage related to loss of consciousness, and also improve the anesthesia monitoring or sleep monitoring based on the brain activity. And that's something that we are going to look at towards like week 10, 11 of the lectures as well. So that kind of brain imaging data is one part of the critical data for consciousness research.